solar radiation along the model surfaces. Our building is interesting in a sense that all the blocks are interlocking each other. So what happens is that when one block is facing the sun, it is casting a shadow which basically is shading the other block. So they are interlocking each other. So this will help us to expose lesser to the solar, the thermal heat gain. Beside that, as from the pictures you can see that the surface shown in the yellow actually is has a more exposure to the sun. So what we have done is that we have placed the solar panels on the rooftop. So those solar panels is a way to achieve the electricity. Beside that, it helps us to it helps us to get a kind of a shading for our concrete below to the roof. Next one, I will move on to the wind analysis. Wind analysis actually is help us to simulate the wind speed around our building site. So wind analysis, as you can see from the diagram, that most of the edges have the higher wind pressure. So what we can do is that the architects can mitigate wind effect on the tall buildings by designing the form aerodynamically. Next, I will pass to Terry.
So now I'm going to talk about the conventional procedure. So in this grand chart, you can see the superstructure and other materials. And next one you can see the conventional will take almost like 2 years to complete. And the next slide is showing that the construction procedure of PVVC. So the PVVC construction will take only 15 months. And next one, we are going to talk about the cost estimation. For the conventional, the building will cost around 20 million in estimate. For the PVC one, it will cost around 15 million in estimate. So for the next one, I will pass my time to No.
So under cost savings, right, according to our solar analysis, we try to use the solar panel on our roof to solve the problem. So solar panels are one of the easiest way and simplest way to go green. So we use the solar panels on our roof, and the one we are using, the panel is called monocrystalline algae panel. Why are we using that? The main reason is much better performance and efficiency, weight, and the cost per watt is lower than the other panel. In the lower part, we calculate more details, but I will go through, assuming that our panels operate for 4 hours a day, right? We got the 92 panels on our roof, so total cost will be 9,000 a year. We can save that amount. For 5 years, we can save about 200K. So under computational approach, right, we use Dynamo to calculate the areas of floor and volume of the column. Under collaboration and conflict resolution, we use Navisworks to detect the clashes. Actually, we use the PPVC method. That's why, as you can see, we don't have much clashes in the day. After that, we use Revizor to solve those problems. And here are the softwares we use in our project, like showing details. Like summary part, I will pass to.
I'll summarize our presentation with actually the teamwork, motivation, and communication are the things actually that help us to complete our project on time. We are people from the different discipline actually, so what we did is that we elaborate and share our speciality with each other to complete our model on time actually. We would like to thank our organizers actually for giving us a platform actually to design our own building and work together and produce our best product on stage. Thank you so much. We have a video to show actually. Thank you so much.
Actually, we are looking for that one. Sorry. Yeah.
Actually, this one is based on what we're learning actually. Our course is just learning the PBVC. Yeah. So actually we found out there is 30% saving. Yeah. Because our course we just learn this course. Yeah.
There's a mathematical mistake here in the first place. 9,000 here times 5 is 40,000.
9,000 is already deduct the solar panel price. So we, in the box, right? 52702, that one is for 1 year. After deduct the solar panel price is this amount. So we multiply this one 4. We multiply this amount to 4 and we got this amount. We got 92 panels, right? So we calculate the price of that. Yeah, so solar panel price will be 43,000.
Where does the 210,000 comes from and 210,808?
Sorry?
The last in the box, saving for 5 years. Okay, I understand your 9,000 because you already taken away your
Price,
cost.
yeah.
But your 210,808, yes. Where does this figure come from? I can't
This
find.
one, 52702 multiply 4 years, get this amount. So I plus this one and this one can get 5 years amount.
Because that's cost, that's not the savings. Because your 210,808 and the figures, what is your yearly savings that you are generating?
Yeah. Yearly savings is 9,000 for 1 year and 5 years for about 200K.
So if I wait, for example, I own the building, so each year I pay less $9,000 for electric bill, right? My bill per month, per year comes, I pay 9,000 less, correct? Is that correct? Is that what you're saying? That's what I'm asking. So I pay less lah. Each year I got $9,000 I can put inside my bank. And then how does this 219 saving? In 5 years time, do I save $219?
Yes.
How? Because each year I can only put 9,000 into my bank, right? So how do we accumulate to 200,000 in 5 years? Unless I go shut. There's some misunderstanding here. Yeah, in the
Judges, I extend my sincere apology to all of you. I guess there is some error on our behalf actually. There should be 45,000, not 219,000. Sorry.
okay. Can I understand you all had some costing? So how much does the all the panels cost? My initial cost to buy all the panels is this one, right?
Yeah, this one, yeah, correct.
So no, but this is not the only amount that I pay, right? 43,000 is not the only amount I pay, right? For all the 92 panels, how much am I paying them for? In order to buy 92 panels, how much is it? It's dividing the cost,
Right,
right?
I think the 52,000 is actually energy cost if you use the solar panel. That's why they use the 52,000 minus energy cost. So it's 9,000 for the cost of the first year.
Roughly.
So they assume that the solar panel savings per year is 52,000. Understand? Yeah. But based on the calculation, it seems to be that. Okay, never mind, it's okay.
Okay, maybe I just want to understand a little bit. Just now, you all mentioned that you all have some algorithm to calculate your wooden panels and angles, right? Can you elaborate a little bit on that because we don't see it.
So actually, right, it's in a fixed position, which is like vertical straight. So because the sun is coming in from this side, this way. So the sun when it's coming this way, right, we are going to actually use this area to come and shade off certain areas. So it's not totally no blockage, totally no sun that is coming in. There still have sun, just that.
It's under your solar simulation.
Sorry, what's your question again?
The panel that you all, because during your presentation, you all mentioned that you all did some simulation of the angles of the panel and that helped with the design, but I don't see it anywhere. If it was verbal, but yeah. So just want to elaborate. If you all have anything else to add on.
Okay, so in the solar analysis, actually, the wooden panels can't be seen actually, but if I show you the 3D picture of our building actually, then from there you can see actually, basically it's split.
Is it this part here? All these are the wooden?
Yes, those facing east and west actually, the windows, in front of the windows we have placed the wooden panels.
Actually, it's fins.
It's just like you can see.
Okay. Anything else?
I want to ask, you have this very like jagged shape to the building. How did you come up with that shape? What did you do some kind of analysis, some kind of algorithm, some kind of computation that led you to that shape?
So for this, right, actually, we kind of found out that by doing this, because there is shade, providing shade, it actually helps to save the heat back.
No, but of course there are many ways by which we can arrange. Let's say fifth floor, I have, let's say every 10 meters I have one part of my building footprint stick out. How did you come up with a shape to say that it's one particular shape over another? You know, the combination of in and out. How did you derive that? Or did you just like kind of like yeah.
We find that this is actually the best position for our building so as the design actually, because when we did the analysis, especially the shadow analysis, we find that our blocks are intersecting each other at that angle actually, that it casts the shadow or shading the other block behind. So in a way that the block, our building is not a form of one block which is facing the sun. It's like one block which is facing the sun, it is shading the other, but there is one other block which is shading the first one.
Yeah. So, but how do you know that that's the best? In fact, I understand the outcome you want is you want one element of the building form to shade another one. I understand that that's the outcome that you're trying to achieve. But if based on that outcome that you want, how did you know that this particular massing is the one that achieves that outcome the most? I'll give you an example. For example, I borrowed this water bottle. Okay, I borrowed this one. So for example, this is it's a 5-story building, right? So let's say, for example, you have one building massing that is sticking out like this, right? And then after, let's say, 15 meters, another building massing sticks out, right? And for example, that's your layout. Okay. How do you know that, for example, between this building massing